Okay, so we are going to balance equations today. And first thing you need to be able to do to balance equations is count atoms. So how many atoms are of each element are in each of the following compounds? So remember the subscripts tell you how many atoms you have. So I have three elements: carbon, hydrogen, and oxygen. And I'm going to look at the subscripts. So I have 9 carbons, I have 8 hydrogen, and I have 4 oxygen. All right. And then here I have calcium carbonate. So I have 1 calcium. I have 1 carbon, right? If there's nothing there, that means there's 1. All right. And this 3 goes just with the oxygen. So I have 3 oxygens. Now I've got magnesium hydroxide. So I have 1 magnesium. And this 2 is outside these parentheses. So that means I have 2 hydroxide ions. So that doubles the oxygen, so I have 2 oxygens. And it doubles the hydrogen, so I have 2 hydrogens. All right, and here I've got 7 carbons, 5 hydrogens, and the 3 is outside these parentheses, so I've got 3 of these, so that would be 3 nitrogens, and it would be 3 times 2, which is 6, so that would be 6 oxygens. All right, because that means I have 3 moles of nitrogen dioxide. Right, 1, 2, 3. So I have 1, 2, 3 nitrogens and 2, 4, 6 oxygens. Okay, so now we're going to balance the equation. So what does that mean? That means you want to have, with the reaction, it means you want to have the same number, right? Balance means equal, right? The left side is equal to the right side. So that brings into the law of the conservation of mass. Very, very important. All right, conserve means to keep the same. All right, mass, remember, is matter, okay, all the elements, what things are made out of, and that cannot be created or destroyed in a chemical reaction. All right, mass is conserved. So we saw that in that beginning of the universe video when we first started talking about atoms and protons and electrons and neutrons, that all the matter that's been in the universe, that has never been created or destroyed. All the atoms that we have been around forever, which is pretty amazing. So what this has to do with a chemical reaction is that basically you want equal numbers, all right, of each type of atom for the reactant and the product side. All right, that is what the conservation of mass means. All right, here's a demonstration of that. Notice you've got some vinegar and baking soda, and when you combine them, it makes a gas, right, that blows up the balloon. But notice on the scale, the mass of everything separately, vinegar and baking soda, is the same as the mass of that solution and the gas. So your coefficients are the number in front of a reactant or a product, all right? It's always a whole number, like 1, 2, 3, 4, 5, a counting number. And what it does is it multiplies things, just like in algebra, right? If I had 3 2 X's, that means I have 6 X's. If I have 3 moles of methane, right, that means I have 1 methane, 2 methanes, I have 3 methanes. So that means I have 1, 2, 3 carbons, and notice I add up 4 plus 4 plus 4 is 12 hydrogens. So 3 times 4 is 12, and 3 times 1 is 3. Good. Okay, so there's 3 commandments, and it's 1 commandment. And the thing is, you can only change the coefficients. All right? You cannot change the formula. All right? The subscripts have to stay the same. If you change the subscripts, you're changing what the compound is. All right? So all you're changing is the coefficients. And the steps are easy. There's really just 3 things to do. You're going to write the elements. You're going to count the elements on the reactant side, and you're going to count the elements on the product side. So write the elements, count the atoms, and then you change the coefficients. All right, because all you can do is change the coefficients. And then what you have to do, though, is you have to check to make sure it's balanced. And you'll see why after we practice some. So step 1, if I'm going to balance this, I'm going to write down the 2 elements, hydrogen and chlorine, and then I'm just going to count my atoms using this. The subscripts tells you how many I've got. So I've got 2 hydrogens and I have 2 chlorines. Now over here, I only have 1 of each. So what I have to do is I need 2 of each, right? I want it to be 2. In order for this to be balanced, this side has to be 2 and 2. Well, how can I change that? Put a 2 in front, right? 2 times 1 is 2. So 2 times 1, so I have 2 hydrogens and I have 2 chlorines. Check. And that's the same on both sides. So that would be balanced. Now, sometimes if you have multiple choice tests, you would write the coefficients. So the coefficients, if there's nothing there, it would be a 1. So 1, 1, and then 2 would be my answer. All right, so now here I've got hydrogen again. I've got oxygen. And so now I'm going to count them. So I have 2 hydrogens and I have 2 oxygens on the left. That's what those subscripts mean. So on the right-hand side, you have 2 hydrogens and 1 oxygen, right? This 2 only goes with the hydrogen. This means I have 1 oxygen. So I need to double my oxygen. So 1 times 2 would be 2, so I'll put a 2 in front. So now I have 2 oxygens, but now I also have 2 times 2, I have 4 hydrogens. So I've got to come over here and make it so I have 4 hydrogens over here. 2 times 2 is 4. So I'll put a 2 in front. 2 times 2 is 4. So now I have 4 hydrogens here and 4 hydrogens here. So check. 2 oxygens here and 2 oxygens here. So check. All right. And then now here I've got 10 oxygen and hydrogen. All right, so 1, 2, 2. It's probably easiest just to do all the reactants and then do your products. So I have 1, I have 2 hydrogens, and then I have 1 oxygen. So I've got to double up my oxygen. So 1 times 2 is 2. So I'll put a 2 in front, right? Now that doubled my hydrogens. So now instead of I have 2 times 2, I have 4 hydrogens. All right, and so now I'm going to have to double up this. So 2 times 2, so I'll put a 2 in front here. All right, and now everything looks balanced. I'll just do one last check. 1, 1, yep. 2 and 2, so check. And then 4 and 4 for hydrogen, so check. And then I'll put in my coefficients would be 1, 2, 1, 2. So that would be my final answer. All right, now this is a bit trickier because my oxygens are split up here. All right, but I'll just list them out. I've got carbon, hydrogen, and oxygen. So I've got combustion happening here, right? I added oxygen to a hydrocarbon, and now I've got a carbon dioxide and a water. So that's combustion. So I'm just going to count here. So 2, 6, 2, and then 1, 2, and then now I've got 3 hydrogens or oxygens. All right, but it's a little tricky because they're split up here. So notice over here I can only have an even number of oxygens, right? So and over here, so that means this has to be even over here. So this would always be even no matter what I put here because I'm multiplying by 2, right? If you multiply by 2, it's always even. So that means this has to always be even as well. So if I look at my hydrogens, right, I have to have 6 on both sides. So this would be 3, right? Would give me 6, but that would be 3 oxygens. If I put a 3 here, that would be 6 hydrogens, but then that's 3 oxygens. And that would be 4, 5. So that's going to be, if I have 3, that's going to be an odd number. So this has to be an even number. All right, so let me erase that. All right, so I've got, so I could have 4 here. If I put 4 here, right, that would give me 8 hydrogens, right? And then over here, though, I only have 6. So I need to think of a number that will give me a multiple of 8 and 6. All right. So that could be, if I count by 6s, that would be 6, 12, 18, 24. All right. And if I count by 8s, that would be 8, 16, 24. So maybe I'll shoot for 24 hydrogens. So if I put a 4 here, right, that would be 24 hydrogens. 6 times 4 is 24. And then 2 times 12, right, would be 24. Oops, so I have 24. Erase that. So I have 24 hydrogens. And you know what? Let me erase right here. All right. Okay, so now how many oxygens do I have? Well, that means I have 12 plus 2, I have 14 oxygens. So I could easily get 14 oxygens here. And then now that means, although, you know what, I'm going to do that last because I got to balance my carbons. I have 4 times 2, I have 8 carbons. So I'm going to have 8 carbons here. All right, so let's go back and erase this. So this gives me 8 carbons and 8 carbons. All right, and this gives me 6 16 oxygens, right? And 12 oxygens. So 16 and 12 would be 28. So I would put a 4 here, or 14, I mean. 2 times 7 is 14. Okay, so that gives me 28. All right. So let's see if that is balanced. 8 carbons, 8 carbons, so check. 4 times 6 is 24 hydrogens, and 2 times 12 is 24 hydrogens over here, so that works out. And then now I've got 28, 2 times 14 is 28, and 16 plus 12 is 28. So this is 28 and 28. All right. But you know what I'm noticing is that all of these are even, right? All my coefficients are even. So what that means is that 2 is a factor of all of them. I can divide them all by 2. All right. And so that is balanced, but you could also, right, if I have 4, if I write that answer down, 4, 14, 8, and 12. All right. They're all even, so that means I could divide them all by 2. So 4 divided by 2 is 2. 14 divided by 2 is 7. 8 divided by 2 is 4. And 6 divided by 2, 12 divided by 2 is 6. So remember we talked about empirical formulas and molecular formulas. So it could go down, this is the least, this would be the empirical formula. All right. So that would probably be the better answer there. All right. Oh, good. This looks much better. Magnesium, oxygen. 1, 2. 1, 1. So all we have to do is double up our oxygens, right? So we'll do that by putting a 2, because all you can do is change the coefficient. That doubled the magnesium. So I need to come over here and double my magnesium over here. Now I've got to check. All right, so I've got 2 magnesium, check. 2 oxygen, check. All right, so my coefficients would be 2, 1, and 2. All right. Here is another combustion one. Actually, I think that's the same, or it looks similar. It's not quite the same. All right, let's see how we do this time. So 1 carbon, 4 hydrogens, 2 oxygens. 1 carbon, 1, 2, 3 oxygens, and 2 hydrogens. All right. Same thing though, I gotta have an even number of oxygens. So this has to be even right here. So let's see, I want to have 4 carbons, right? Or 4 hydrogens, right? So if I put a 2 here, that would give me 4 hydrogens here. And that would give me 2 plus 2, that would give me 4 oxygens. And we can make 4 oxygens over here, right? We'll just put a 2 in front. 2 times 2 is 4. And then let's see. Wow, that was way easier. So don't panic if you got a combustion one. But we do need to check. So I've got 1 carbon, 1 carbon. So check. Hydrogens. 4 hydrogens and 4 hydrogens. Check. 2 times 2, so 4 oxygen, and then I've got 2 plus 2 is 4 for my oxygen. Oh, good. Awesome. So, it can be tricky. So some things you might want to do, if you have polyatomic ions, you keep them together. You saw how hard it was when the oxygens were separated. You definitely don't want to mess up with the polyatomic ions, so keep them together. Water sometimes is helpful to write as HOH. Okay. And then the even-odd balancing rule. If you have an element with an even number of atoms on one side and an odd number on the other side, it's easiest to first find the least common multiple. Okay. Alrighty. So, let's write down the elements. Do our counting. All right, so we got an even-odd situation here, right? So it's just like when we were writing formulas, you just count for least common multiple, just count by 2's. So 2, 4, 6, 3, 6, 9. So 6 is my least common multiple. So how about we try to get 6 oxygens on each side. So 2 times 3 would be 6, and 3 times 2 is 6, right? All you can do is put a coefficient. So 3 times 2 is 6, 2 times 3 gives me 6 oxygens. But now I have 2 times 2, I have 4 aluminums. So luckily aluminum's over here all by itself, so I can put a 4 in front, it doesn't change anything. So now I've got 4 aluminums, and 2 times 2, I've got 4 aluminums. So my aluminums check out as well. So my coefficients would be 4, 3, 2. So that is a synthesis reaction, right? You have 1, 2 reactants, and you end up with 1 product. All right, so here we go. We've got an acid, sulfuric acid, and a base, right? The acid and a base. And I end up with an ionic compound and a water, a salt and a water. So I've got neutralization here. So let's balance though. I'm going to write out my elements. Hydrogen. Here's a right, sulfate. So I'm going to keep that all as one element. And I've got my lead and my hydroxide. All right. Now since I have a hydroxide here and a hydrogen here, I'm going to turn this water into hydrogen and hydroxide, right? Because it's two H's, H2O. All right, so that will help me with counting these things. So I've got 2 hydrogens, 1, right? This 4 doesn't mean I have 4. 4 is part of that ion. SO4 is, I have 1 of those. I have 1 lead, and now I've got the 4 on the outside, so I have 4 hydroxides. And then here I've got 1 lead, and I've got 2 sulfates. And then here I've got one hydrogen and one hydroxide. Okay. So now I'm going to just try to balance these out. I'll just go ahead and start with my hydroxides. So I need 4 hydroxides over here. So I'm going to put a 4 in front. Right? That means I have 4 hydrogens and 4 hydroxides. So I need 4 hydrogens on the other side. So I can do that by putting a 2 in front, right? 2 times 2 would give me a 4. Okay, and then that also gave me 2 sulfates, so that's good. And my leads were already balanced 1 and 1, and then my hydroxides are 4 and 4. But I'm going to go do one last check just to be sure, because you can see it gets kind of messy. So I have 2 times 2 is 4 hydrogens over here, and then I have 4 hydrogens over here. All right, and then I have 2 sulfates here, 2 sulfates, and then this is saying I have 2 sulfates. Then I have 1 lead here and 1 lead here. And then I have 4 hydroxides and I have 4 hydroxides, so that checks out over there. So my coefficients would be 2, 1, 1, and then I would have 4. And that is my final answer. Alrighty. So here we go. Again, I have an acid and a base. Right, I have sulfuric acid, so that is H and SO4. And then here's my ammonium and my hydroxide. So I'm keeping all my polyatomic ions together. And I'm going to make this into HOH. All right, and then now I just count. So I have 2 hydrogens, 1 sulfate, 1 ammonium, and 1 hydroxide. And then now this is saying I have 2 ammoniums, 1 sulfate, and 1 hydrogen, and 1 hydroxide. Alrighty. So I've got I'll go ahead and double my ammoniums over here. So to have 2 ammoniums, I would put a 2 in front. And then that doubled my hydroxides. So I'll put a 2 over here. So that doubled my hydroxides. And then that doubles my hydrogens. All right, and I think that's balanced now. Let me check to be sure. All right, so I've got 2 hydrogens and 2 hydrogens. And then I've got 1 sulfate and 1 sulfate. And I've got 2 ammonias and 2 ammonias. And I've got 2 oxides and 2 oxides. So that was actually 2. All right, so that works out. And so my coefficients are going to be 1, 2, 1, 2. All right, and this just takes a lot of practice. All right, and so good luck. Have fun. It's like a puzzle.